Hi, I'm Yu, and I'm gonna record a video for question number 1 in homework 6 for the course probability and stochastic processes. So in the first question, it mentioned that this function had a joint density function, and the first little question asks us to find a, so that the both defined function is a valid joint density function. So this question is kind of simple. So we just need this equation to be 1, so that the function will be a valid joint density function. So after calculation, we can see that 4 divided by a equals to 1, and so that we can get a equals to 4 to fulfill that the function will be a valid joint density function. So, and for question number 2 and number 3, it asks us is Rxy uncorrelated and Rxy independent? Well, so these two questions together. So the exy is the integral from negative 1 to 1, and integral from negative 1 to 1 xy 1 plus xy divided by 4 times dx dy. So by calculating this, we can get this this equation equals to 1 divided by 9, and we also need to calculate ex and ey, but right here I calculate ex. The x equals to the integral from negative 1 to 1, and times the integral from negative 1 to 1 times x times 1 plus x times y divided by 4 times dx dy. And after I calculate this equation, I get the final value as 0. So I do not need to calculate ey, since this part ex times ey will be 0, since ex is 0. So we can get that we can find out that exy does not equals to ex times ey. So this gives us the conclusion of these two questions. So xy are not uncorrelated, and xy are not independent. And the fourth question asks us to find the joint density function of x squared and y squared. So first I'm gonna set the z equals to x squared and w equals to y squared, so that I can write the matrix J, which will look like this, and it is equals to 4xy. So since I said d equals to x2 and w equals to y squared, so we're gonna have 4 roots. So to find out fzw, I'm gonna set for 4j, since there are 4 roots. So fzw equals to fxy of square root of z and square root of w divided by j1 and j2 and j3 and j4. And this is negative, this is negative, and these both are negative, which is we can get from the matrix. So after calculation, I get the final answer of 1 divided by 2 times square root of z times 1 divided by 2 times square root of w. So we can get when z is less than 0 or z larger than 1, and when w less than 0 or w larger than 1, we can get the zw equals to 0. Okay, let's see the wait a second. Let's see the question number 5. So question number 5 asks us to prove or disprove that x squared and y squared are independent. So since fzw equals to fzz times fww, So we can get that fz z is equals to 1 divided by 2 times square root of z for 1 z in this range, and fw w is equals to 1 divided by 2 times square root of w in this when w is in the range from 0 to 1. So we can from this we can tell that x, y are totally independent. And that's the answer for this question. Thank you for watching.